copy of the powers, quote unquote. Here on the flanks of Kilauea volcano in Hawaii, Francine, one of the members of the research staff of the Hawaiian Volcano Observatory, is showing us kindly how one sets up to make a GPS type measurement. You will notice that she's put up a tripod and she's attaching to it several mechanical devices which help in the leveling of an antenna which must go on top and the locating of this antenna in an exact way against a benchmark. A benchmark is cemented in permanent place on the surface of the earth. Some of them have been implanted by the Coast and Geodetic Survey, others by the U.S. Geological Survey, and those are map reference points for the surface of the earth. So if you want to measure distance from A to B, you start with a reference point, much like in surveying, and this is being set up by Francine over one of the benchmarks, and any other distance measurement that wanted to be made could be made relative then to this one. The overhead satellites will be communicated with from the antenna that Francine is now connecting the power source for the battery, and the white disc on top of the tripod is that antenna. Can you move the rod? So what you're doing, your plug-in shows, that's all.
Okay, I can do that again. Let me get an antenna cable.
Okay.
Level that later. What would you like me to start off with?
Just whatever you would do if you're making a measurement.
I mean, should I be talking to you like I'm setting this
yeah,
up?
Just if you can, yeah.
Okay. You don't want to watch me coil antenna cable, right? Let me uncoil this.
Francine is now going to connect the yellow integrator computer on the ground to the antenna so that information coming down from the satellite can be collected and integrated into the yellow computer.
Should I start?
Yeah.
Okay. What we're setting up here is a GPS unit. It's a L1, L2 type antenna. It's a geodetic antenna that is different from your handheld GPS units, which only get a precision of perhaps 10 meters. These, after post-processing, can get down to better than centimeter type accuracy. What we have here is the yellow Trimble units. We have an antenna situated on a tripod with a tribrac, a receiver, and our power source. So what I'm going to do now is center the antenna precisely over our benchmark over here. So once we have our antenna leveled, we hook up our antenna.
The antenna is passive, or is there active
Oh, it's just a receiver. There's nothing being broadcast out of this antenna. That's why we're able to use it at airports and such areas, because it's only a receiver. We hook our power supply to our receiver. And then what's important is we also get a height from where the antenna is to the benchmark, because what we're interested in is the precise position of this benchmark on the Earth. Now, heights with GPS, the heights are measured not to sea level, as some might think, but to something we call the ellipsoid, which is a mathematical average to the center of the Earth. So we'll take our height right now. And for this antenna, we're taking the slant height, and when we do our processing, we'll calculate to get the true vertical height. So we measure from the center of the antenna, or the benchmark, and the slant height in centimeters to the antenna. And we usually, for accuracy, we'll go ahead and do this for 3 measurements on each side of the antenna. And it also makes certain that our antenna is level. And once we're done setting up our antenna, we go ahead and program our receiver and leave it there for at least 8 hours and make measurements.
In the lesson plan, you will have seen and hopefully explored a website link to the Trimble site that actually shows animation of how the overhead satellites can triangulate between themselves and between the ground stations, such as Francine has set up. Here Francine is programming in the data to communicate from the station that she set up for us, and she's telling the computer that this is a new station, and she, just to be funny, named it after me, after Gene, and she's asking it to find how many satellites are overhead from horizon to horizon that can speak back and forth with themselves and with this station. And she's finding that there are 9 satellites that are within line of sight of this station at this time. Number 27 is, in fact, turning out to be not in a healthy condition, and that is explained by Francine.
Satellites we're seeing in the sky. I'm amazed that antenna's actually tracking data. That's amazing. Huh.
For the sake of the narration, amazing because we thought this one was broken.
Yes.
Okay. Otherwise, it's as expected.
Yes. And here's our 2 channels. We have the L1 channel and the L2 channel. And we're checking on the health of the satellites. We have 27 healthy satellite vehicles, or SVs, and 1 unhealthy satellite, number 27.
And unhealthy in this case means it's over the horizon, or the satellite is sick.
Basically, the satellite is sick and needs to be reprogrammed by the ground stations. There's ground control stations here in Hawaii, Colorado, and several other around the world that continuously check on the health of the satellites broadcasting their data. Sometimes if a clock goes off or the programming is in error, the ground control stations will upload the correct information to the satellites.
So it's not the defocusing that the military does
No,
to thwart terrorism or whatever.
no. That's something called selective availability, and that's been turned off. But there's still spoofing, which the military can turn on and off at will.